Bonjour, welcome to Wahsa Education Center's Radio Zoom classes. This is MBF3C, grade 11 college math, and I am the teacher, Bronwyn Slate.
Unfortunately, this week you cannot participate live as our studio is under some construction and you can't call in. So this lesson is pre-recorded, though we are broadcasting on the radio at 91.9 FM and on the television at Bell Express View channel 972. Usually you will be able to join live through the Zoom link or call into the Wahsa studio to ask questions, but for this week, that is not a possibility. Our classes are scheduled Monday through Thursday from 10 until 11 in the morning, and we are in our first week of our 9-week course. So to know what work to submit as we go through our course, the support questions, the ones with a little pencil icon, are not for marking. You decide which ones and how many to do. If you understand a concept, feel free to skip questions. You don't have to do them all just because they are there. If you need more practice, let me know and I'm happy to send you more practice. All of the answers are at the back of your book for the support questions, so please check your work to make sure you're on the right track. The key questions, the ones with the little key icon, are the ones to submit for marking. So please do all of these questions showing all of your work, your steps, and your thinking. This way I can understand what it is that you understand, and I can support you and help you if you are making errors. So then how do you submit your work for marking? Well, there's 3 methods. The first method is to scan and send your work electronically. You can scan your completed work through a device. If you have an Apple device, the Notes app has a scan function, and if you have an Android device, the Google Drive app has a scan function. These are free apps that generally come with these devices and so are already on them and are fairly straightforward to use. If you need some support learning how to do that, I have videos on my YouTube channel that walk you through step by step how to use both these individual apps. They're under my playlist called the Tech Tutorials, and you can follow there along to learn how to do that. Once you have it scanned, you can then send it either by email to studentwork@nnec.on.ca and CC it to bronwyn.slate@nnec.on.ca, or you can send it through Facebook Messenger, where my name is B. Slate Wahsa. A quick moment of recognizing why I'm suggesting scanning versus just taking a picture. You can take a picture if that is what works best for you. If that's the only option that you have, that's fine. But if you scan using an app on your phone, it means that it's easier to create one file with all your pages so we don't lose anything. It's faster because it simplifies the image, and that makes it a smaller file, which is easier to send. This is why I encourage scanning, but again, if that doesn't work for you and you need to take pictures, if that's the best way for you to send work electronically, that is okay. If you want to learn how to scan with your smartphone, with your device, I'm happy also to walk you through that and to support you. If watching the videos isn't a great option for you, just let me know. I'm happy to support however I can. All right, so our second method is to drop off your work in Sioux Lookout. We have an outdoor mailbox at our location 74 Front Street. We are the bright red building next to the post office, and we have a small white mailbox next to our side entrance. So just put your work in there and we'll get it back to you as soon as possible. The third method is to hand your work into your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. Students are also welcome to hand in their work by fax if that's something you have access to. We just ask that you give us a call or send me a message to let us know that you have sent a fax, as we've had some instances where things get faxed, but they don't get received. So we want to make sure that we get your work. If you'd like to connect with me through social media, both my Facebook and my YouTube channel are under the name B. Slate Wahsa. You can friend me on Facebook and subscribe to my YouTube channel, and then every time I upload one of our Radio Zoom classes videos, you will get a notification. so that you know it is there. It's easy to find. As I've said, all of our Radio Zoom classes are recorded and posted to YouTube shortly after broadcasting. So everything is there for you to find as accessible as possible. Also, on my channel, there are short videos that explain common errors and confusing concepts. So this is a really good place to go if you are struggling with something, or if you're feel like you're missing a piece that isn't necessarily a new concept, but is something that you've struggled with in the past. There might be something there on my YouTube channel that addresses this and just makes it a little bit easier to find that help opposed to doing a general online search. Math is a really visual subject, so I strongly encourage you to access the videos. Listening to me only on the radio is not going to give you the full experience, and things most likely will not make as much sense as if you access the videos and see what I am talking about on the screen. If you cannot join me live through Radio Zoom, if you cannot access the YouTube videos, you don't have reliable internet, so those are not options, let me know and I'm happy to send you a copy of all of our recordings so that you still can get the full experience and set yourself up for the most success. If any questions or concerns, please reach out and contact me. My primary focus in my position is to support you, my students. You can send me an email at bronwyn.slate, that's spelled BRONWYN.SLATE@nnec.on.ca. Connect with me through Facebook, where my name is B Slate Wahsa. B Slate is all one word, second word Wahsa. Give me a call at the office at 807-737-1488 or toll-free 1-800-667-3703. My office hours are Monday through Friday, 8 a.m. to 2 p.m., though I teach from 9 until 11, so that's not a great time to try to get a hold of me.
All right, we are continuing on today with lesson 2. We will wrap it up, but we're continuing with polynomials and factoring today. So our learning goals for this lesson have been that you will understand and implement the distributive law, which is what we focused on last lesson, and you'll be able to factor trinomials. So our success criteria 1 and 2 we covered last lesson, where you can explain and identify polynomial terminology and you can multiply binomials. And then number 3 is new for today that we're going to cover, and you can common factor and factor trinomials when a is equal to 1. But first, let's activate your brain with a bit of mental math. I don't believe in Mad Math Minutes. They are stressful and don't actually help students learn facts, though facts are important. So instead, we work on developing strategies that we can use in various situations that help increase our comfort and our confidence with manipulating numbers. Our question today is 59 divided by 3, and we're using the strategy of sharing in groups. And so many folks will go and say, okay, if we're dividing 59 into 3 groups, we'll maybe make 3 groups and then go through and add 1 dot at a time to each of these groups until you get up to 59. And that is totally fine. That works, but it's a bit of a long process. So instead, what you can do is you can share in throughout groups. So I can say, okay, well, I'm going to put 10 in my first group, and then 10 in my second, and then 10 in my third. And that I have done 30 things already out of my 59 things. So I don't have another 30 things, so I can't do another groups of 10. But I can do 5 and 5 and 5. So that means that I have now shared 45 of my 59 things. Okay, so now if I've shared 45 and I have 59, that means I have 14 left to go. So I'm going to share 2s So I did 2, 2, 2, and then I'm going to do another 2, 2, and 2. So now I've got, so I did 10, 10, and 10, so that's 30, plus 5, 5, and 5, which was another 15, so that's 45, plus 2, 2, and 2, 2, 2, and 2, so that would be 12. So 45 plus 12 would be 57. And then I have 2 more things left, but I can't share them equally into my groups. So that means that if I divide my things into 3 groups, one of my groups, each of my group is going to have 10 plus 5 plus 2 plus 2. So 10 plus 5 is 15, plus 2 is 17, plus 2 is 19, with a remainder of 2 that I can't divide. So 59 divided by 3 is 19, with a remainder of 2. And that's how you can share in groups. So you can still do that you have this many groups, and then by sharing by clusters of numbers and sharing just instead of just sharing out by one can make it a little bit faster and more efficient than just sharing out by one, by one, by one. All right, quick minds on a reminder of what we did yesterday or in our last class. So we looked at multiplying binomials. So our example is 3x minus 7 times 5x plus 2. We used the box method as well as algebra tiles. I'm going to use the box method here. So I have 3x minus 7 down one side and 5x plus 2 along the top on the other side. And I've drawn a little box inside, or grid, I guess, and I have 3x times 5x is equal to 15x squared, and then 3x times 2 is equal to 6x, and then negative 7 times 5x is equal to negative 35x, and then negative 7 times 2 is negative 14. And so the box method and the algebra tiles are all just organizational tools. They're just ways to organize your information to help you get, make sure you do all of the steps. Then we need to add our like terms or combine our like terms. So remember that x squared, here we have 15x squared, but there's no other x squared terms, so we can't add them together. Then we have plus 6x minus 35x. Those are both x terms, so we can combine those to be negative 29x. And then negative 14, there's no other constants, so we just leave that as negative 14. So our final answer is 15x squared minus 29x minus 14 is what we, when we were multiplying 2 binomials. And that's what we did in our last class. So the other thing we need to remember today is factors. So we need to remember the language of what it means to be a factor. 2 times 5 equals 10. This should be a fact that most people are comfortable with. The 2 and the 5 are called factors of 10 because they are numbers that multiply by something to get 10. 10 is called the product. I'm going to use the word factors a lot in this lesson. The product I might use a little bit, but mostly we need to remember that factors are the numbers that multiply to be our final result, to be our answer, to be our product. So for example, what are all the factors of 24? So we're thinking about what are all the numbers that multiply by another number to equal 24. And right now we're just focusing on multiplying 2 numbers together to get our product. So 1 times 24 is equal to 24. So 1 and 24 would be factors. Also, we need to be thinking about our negative values too, because negative 1 times negative 24 is equal to 24. So negative 1 and negative 24 are also factors. 2 times 12 equals 24, and negative 2 times negative 12 equals 24. 3 times 8 equals 24, and negative 3 times negative 8 equals 24. 4 times 6 equals 24, and negative 4 and negative 6 equals 24. So all the factors of 24 are plus and minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, plus or minus 24. So these are all our options when we are trying to find the factors of 24. The more and more you do this, the more and more comfortable and you get to recognize what the factors are of numbers. It does take some practice. If you need to use a calculator, totally fine to try to figure it out. You might miss them sometimes. Generally, you don't need to know all of them, but knowing that there could be a lot can be really helpful. All right, so that's what we need to know diving into today. Now let's get going with our new concepts. So this is on page 13 of your IEL book, and we are starting to look at factoring quadratic relations, particularly in the form of a x squared plus bx plus c, where a is equal to 1. It's okay if this formula here doesn't mean much to you. Basically what it means is that we have the a, b, and c are all numbers, and we have an x squared plus an x plus a constant. So that's just a general form for a quadratic. It's another form for parabolas. So first, we're just going to look to see the relationship to what we've been doing already. So like we just reviewed, when we're expanding, we go from a question like x minus 5 times x plus 6, and we multiply those together. We expand it is one way that we talk about it, and we get x squared plus x minus 30. So we did this with our visuals, and we had expanding, we had our two sets of algebra tiles on the outside of our area model, and then we were finding the inside when we multiplied them together. That was our expanding to find our binomial. Or sorry, our trinomial, not our binomial. Multiplying two binomials to find our trinomial. So then what we're doing today is factoring, and what this means is that we're starting with the answer. We're starting with what we have inside of the algebra tile square or large rectangle. We're starting with the trinomial, where we have x squared plus x minus 30, and we're trying to figure out what these two binomials are that multiply and give us this amount. So we're factoring is the opposite of expanding. It's kind of like division, but dividing scares people, so don't think about it like that if that doesn't help you. But basically we are doing the opposite, the inverse of expanding. Multiplying the binomials is factoring, where we're going backwards. So we're starting with all the algebra tiles, and we're having to figure out the two pieces that go on the outside that help us, that would multiply to get the inside. So there's a fair number of steps. We're going to first do this visually, and then we are going to do it just numerically. So follow along with me while we're doing it visually, and then we'll go through the steps where you don't need to use algebra tiles or draw these. Again, I will link the virtual manipulatives in our show notes, so you can go and check out that website, and I will put the links for the free apps as well, so that you can use that as a tool. And then I'm also going to show you how to do it just with numbers, but first, to visually conceptualize what we're doing, we're going to do it visually. So our example is, the question is asking us to factor x squared plus 7x plus 12. So first, what we're going to do is we are just going to we're going to visualize what this means with our algebra tiles. So x squared is an x squared term, one of these big squares. And then we have 7 x terms. So we have 7 of these long rectangles that are x terms. And then we have 12 1 units. So we have 12 of these little 1 squares. But if we think about what we've done when we were expanding our binomials, we were going in the one direction. We always ended up having our inside organized in a rectangle that had no cutouts or no parts sticking out, right? They just were always equal. That's how we were able to figure it out, was because everything lined up in a grid. So that means that we need to organize our trinomial in this way, in this similar rectangle or sort of square model, in order to figure out what our two binomials are that are going to multiply to be it. So we're going to rearrange all of our tiles in order to figure out what our binomials are. Again, this is really hard to do if you're not watching along with the algebra tiles, and I will explain how to do it just abstractly later on if you are not able to access the video. So our first step is, when we're factoring x squared plus 7x plus 2, and when we're factoring any trinomial, is that we are thinking about the fact that we're going to have two binomials. That's what, if we multiply two binomials, we get a trinomial. So if we have a trinomial and we're going to factor it into its two parts, we're going to get two binomials. So we just set up two sets of brackets to help keep ourselves organized. Then we think, okay, well, x squared, the only possible way for us to get an x squared term is by doing x times x. There's no other way we can get an x squared term. So our two binomials have to have x and x in order to get, each binomial has to have an x term in order to get x squared. So generally you can, looking at your question, the first spot in your two binomials inside the brackets is going to be an x. Could be a different variable if your variables are different, but for now we're just going to say that it's going to be an x, because we're using an x for this example. Then the next part is we're trying to figure out the two numbers that go in the second part of the brackets. The x part is fairly straightforward. There's only one way to get x squared, but there could be multiple ways to figure out these two parts, that we have to figure out which one is the right method or the right combination of numbers that gives us all of these other tiles. So how we figure that out is we have to remember that our two numbers multiply to be our ones units, multiplies to be this 12, right? If we have in our binomial, we have our one tiles here and our one tiles here. And when we multiply them together in our area model, we get all of our ones over here. So they're going to have to all multiply. Our two numbers are going to have to multiply to be 12. And this is where our factors come into play. So we're going to think about the factors of 12. And one set of factors of 12s is 12 times 1. So I'm going to organize all of my ones, my one tiles, in one long column of 12 rows. Or I could also organize my columns into two columns of 6, because 2 times 6 are also a set of factors of 12. And then finally, I'm going to organize my ones into 3 by 4, because 3 times 4 are also factors of 12. So these are my three options, as that I have 1 times 12, 2 times 6, or 4 times 3 are my options that were going to give me 12, my factors that are going to give me 12. So then I'm going to see, so my next part I need to look at is I also need those two numbers, the two factors that multiplied me 12, also have to add up to be 7. So now we're going to use both these pieces of information. So there's no way that I can multiply two numbers of 12 and 1 in any way that they're going to equal 7. 12 times 1 is 12, and 12 plus 1 is 13. So that one's not going to work. So we know automatically that this option is not going to work. So now we're going to look closely at our other two rectangle options. First, we're going to look at the 2 by 6 arrangement. And how I like to do this with the algebra tiles is I'm going to move each of my X tiles to organize them, to line them up with my rows and columns. So for each row, I put in an X and I fill up all of my rows. I'll have 6 rows, and so I have 6 X's to match them along. And then I have one more X, and I put that along my column, because remember, this is how we lay them out if we're going the opposite direction, if we're multiplying them out. And we can see that we still don't, we need one more. In order to have 2 columns of 6, we would need to have one more x, and we don't have one more x. So this way does not work. We can't organize the factors of 6 and 2 don't work because 6 times 2 is equal to 8, and that is not going to give us 7. So our last arrangement we're going to look at, which was the 4 by 3. So we're going to move our algebra tiles and line them up to fill up our square. And we're going to put 3 along our rows and 3 and 4 x's along our columns, and we can see we filled up all of our rows and all of our columns, and so that completes the inside of our area model. I know that this sounds really weird. It makes more sense if you're actually doing it with tiles. If you're just listening to it, it doesn't make any sense. If you're looking at it, hopefully it makes a little bit more sense. And as we practice, hopefully it makes a little bit more sense. But you can see now we have the right shape where our tiles are all lined up, that they all match. And now we can figure out what numbers we need to make this actually possible. So we need 3 1s in our binomial because we have 3 rows. And we need 4 1s in our other binomial because we have 4 columns. So now we can see, looking at our diagram looks right, such that we have our trinomial is a product of our 2 factors, which we were able to figure out. So now we have x plus 3 is our first binomial. So that plus 3 is the first, goes in that first bracket. And x plus 4 is our second binomial. X plus 4, the plus 4 is the second number that goes in that bracket. And now that's factored. That's all we need to do with our factoring. The work of this is a lot of stuff that happens in your brain or on a side piece of paper or a side, making notes to the side, or using algebra tiles, but it doesn't show up in the lines of our work in the same way as many of our other things do. So we have factored x squared plus 7x plus 12, and we've got the answer of x plus 3 times x plus 4. So let's keep trying another one, because this is a complicated concept. So we're going to factor x squared minus 5x minus 6. So again, we're just going to first pull out our tiles that match our trinomial. So we have x squared, and now we have 5 negative x tiles. So that, remember, we have negative 5x, so that means that our x tiles are negative. And then we have 6 negative tiles, 1 tiles, because we have negative 6. So still, our goal is to arrange these tiles so that they make a complete rectangle, a uniform rectangle. So we're going to try to figure out how we can organize that. Our first step is that we know that we're going to have our 2 binomials. That's what we're doing. We're getting 2 binomials. That's what we're looking for. So we put our 2 brackets, and we can remember that x squared, the only way to get x squared is do x times x. So that goes in our first spot. Our second thing that we think about is that we are looking for 2 numbers that multiply to be negative 6. That is our goal. So we're trying to think of the factors of negative 6. So we can have 1 by 6 arrangement of our tiles, or we can have 2 by 3 arrangement of our tiles. Those are the only ways that we can arrange our tiles such that they end up in a uniform rectangle. So now we think about, we also want our 2 terms, our 2 numbers, to add up to be negative 5, so that we have negative 5x. So we're going to see which of these options does that for us. So looking at this 2 by 3, because that sounds pretty good for adding up to be x, adding up to be 5. We're going to organize our tiles such they fill in all of the columns and all of the rows so that they can fill up our full area model. And this looks pretty good. We have 3 negative x's and 2 negative x's, and so that how it gets our 3 columns and our 2 rows. That looks pretty good. But a negative times a negative equals a positive. So if we had negatives here, if we have negative values to get negative x and negative x, that means that those negative times negative would give us a positive 6, and we don't have a positive 6. We have a negative 6. So this is a trick. Many people would do -3 and -2, but that would give us positive 6. And so that does not actually factor. This does not work because we do not have a positive here. So we can't try that option. That option doesn't work. So let's look at our other one where we have -1 by -6. So again, we're going to move all of our x's over so that they line up with our rows and our columns. And we have 5 x's, and so we have 5 columns. But we're missing 1 column and 1 row. We don't have enough. But remember, sometimes when we were multiplying our binomials, our x tiles canceled each other off. We combined like terms and they canceled each other off, right? So we're trying to figure out, is there some way that we can fill in these because maybe they canceled each other off? So we're going to think about what we call a zero pair. And this is when we think about the fact that a positive x and a negative x would cancel each other off, and so they wouldn't be showing up in our final answer. So if I have a positive x in my row and I put my negative x in my column, because remember those two cancel each other out. So this is still equal to -5x because yes, I increased it by 1 negative x, but I also increased it by a positive x, and so those two cancel each other out. So our value is still the same, and now our rectangle is filled out and it completes our shape. We get this full area shape, which is what we wanted. So sometimes, this is the tricky part with the negatives and positives, is that sometimes you have to think about the negatives and the positives. You can't just ignore that part. You can't just look at the numbers. So this means that we have x plus 1 as our one binomial and x minus 6 as our other binomial. Because that positive 1 times -6 gives us -6 as our final term, and then gives us our -5 because our positive x and our negative x cancel off. So that can be tricky sometimes. And so that's just, sometimes you need to be a little bit flexible in your thinking about, really, does it work that you multiply to be the last term and you add to be the middle term? Okay, so now you can do the support questions on page 14, questions 6A to C. The first ones, that's all you need to know to do those questions. Now we're going to look at factoring quadratic relations in the form where A does not equal 1. This continues to be on page 13 in your IL booklet. So if we have a question like 2y squared minus 2y plus 16, now all of a sudden it overwhelms us. It's different. We don't know what to do with it. So first, what we're going to do, that 2 freaks people out. Let's think about them like our tiles. So that just means that we have 2y squared tiles. Okay, so getting our tiles, we have 2y squared tiles, and now we have 12 negative y tiles because we have negative 12y, and then we have 16 1 tiles because we have 16 positive 1 tiles. So we have a lot of tiles, and that's a little bit daunting. What we can do is we can break these up into 2 even groups, because if we look at them, they divide nicely into 2 even groups, and then we can make our life simpler. So this action of dividing them into 2 even groups means that we factor out this 2, and we're left with y squared minus 6y plus 8. Because what we've done is we've taken out the factor that is for each of these. We've broken it up into 2 groups, and what's left in each of our group is y squared negative 6y plus 8. And our numbers are getting to be smaller and a little bit more manageable. This is called common factoring. And you always want to check to see if you can do common factoring first, because it's going to always make your life easier. It's going to make your numbers smaller and simpler to deal with. So always look to see if there is a common factor. Is there a number that goes or a letter that goes into each of your three terms that's going to make them all simpler. You can break them into that number of groups, and then you're dealing with less things. So when we common factor, what that means is that we can ignore that second group because it's going to be exactly the same thing. So in our steps, how we'd write it is that we'd say, so our question is 2y squared minus 12y plus 16. And we would say it's equal to 2, then open a bracket, y squared minus 6y plus 8, and then close your bracket. So you're going to, now we can just look at how to factor this inside piece, and we can just keep writing the 2, but we don't actually have to do anything with it. We've already dealt with it. And then we do the same thing as before, is that we're organizing our y squared minus 6y plus 8, and we're trying to figure out what the two binomials are to factor for that. So the same rules apply, but now we're looking at this part that is inside the brackets and not the original question because we factored out 2 to make our life easier. So what are, oh yeah, y squared, we know that the only way to get y squared is have y times y. So our first part of our bracket is going to be y for both of our brackets. Now we need to figure out what are two numbers that multiply to be 8. So we have 1 by 8 is our one option, and 2 by 4 is our other option. These are the only two arrangements that work for 8. There are only two sets of factors like this that make this rectangle shape. Of course, we could have 4 by 2 and 1 by 8, but it doesn't matter. The orientation of our rectangles doesn't matter. So now we have to think, what are two numbers that add up to be -6 and multiply to be +8? So first we're going to use this 8 by 1 arrangement. So I've organized all of my negative y's to line them up, and I see that I'm missing 2 rows and my one column, and so I don't have enough negative y's. Even if I put in a 0 pair, I could put in 1 0 pair and I would get enough. I would match that up, but then I'd still be short 1 negative y, and so that doesn't work. I can't just add it in a negative y. I have to add in a negative and a positive in order to balance that off. So this way doesn't work. That arrangement doesn't work. So let's try the other arrangement where we have 2 by 4. So if I arrange my negative at 2 in my rows and my 4 of my negative y's in my columns, I have used up all of my negative y's. I don't have any extras, spaces, or extra y's that don't have a place to go. And this time when we look at it, well, if I have negative times a negative, that equals a positive, and my 8 is positive, so that works. Not only does my arrangement work, my visual arrangement works, but also my negatives times negatives equals a positive, so that works too. So that means that we have 2 rows, so we're going to have y minus 2, right? Because they have to be negative in order to get a negative y, right? Negative y times -1 equals negative y, so these ones have to be negative. And then we have y minus 4, because these also have to be negative in order to get my negative y terms. So our binomials are y minus 2 and y minus 4. So my final answer is 2 times y minus 2 times y minus 4. And this is like when we were doing the opposite of when we were doing the monomial times binomial, right? Where we had to do those 2 steps. We had to do the 2 steps going backwards as well. Okay, so now you can do the questions on page 14, questions number 6, H through I. Okay, so now let's talk about factoring without the visuals. If you don't have algebra tiles, you don't want to use algebra tiles all the time, how do we do it? So we're going to factor x squared minus 16x plus 63. So the first thing we always want to do is common factor first. We want to check. Here, a is equal to 1. We just have x squared. We don't have multiple x squared terms, so that means we don't need to common factor. Then we set up our double set of brackets because we know that's going to be the form that it's going to end up in. Then we look at the squared term, and we say the variable goes in the first spot. So this is x squared, so that means that we're going to have x in the first and x in the second of both brackets, like the first spot of both brackets, because the only way to get x squared is do x times x. Now we're looking for the numbers that follow. So we ask, what multiplies to be our constant? What multiplies to be plus 63? And we're going to find all the factor pairs. And I like to write down all my factor pairs. When I'm not using Algebra Tiles, I like to make a list to keep myself organized. So 1 times 63, -1 times -63, 3 times 21, -3 times -21, 7 times 9, -7 times -9. This helps me keep myself organized and figure out if I have all of my pairs, probably. I'm more likely than if I just randomly pick numbers and see if they work. Again, you figure out a system that works for you, that makes sense for you. So then which of these factor pairs add up to be the coefficient of the middle term? Which ones add up to be -16? So 1 plus 63 is equal to 64? Nope. -1 plus -63 is equal to -64? So no. 3 plus 21 is 24? Nope. -3 plus -21 is -24. Nope. 7 plus 7 is equal to +16. We want -16, so no, +16 does not work. -7 plus -9 is equal to -16. So that one is the one that works. It's not always the last number, but it's good to check to make sure. And you don't have to go through and check them all. Some of them are going to be obvious, and you can go and check the ones that you're not sure about. So those are two numbers that go into our second spots. So we get x minus 7 times x minus 9. It does not matter which order. If you did x minus 9 times x minus 7, both are correct. They are the same. And that's how you do it, just by following those steps. This is a really good screen to screenshot or to take a picture of, to make notes off, because it gives you the steps to follow until you're confident without having to follow like where the steps are memorized or in your brain that makes sense. So let's keep doing one more example. We have 7y squared plus 21y minus 28. So first step, common factor first. We have 7y squared. That means that a is equal to 7. So we have to factor out a in order to get it so that we just have y squared. So we have to think about what multiplies by 7 for each of these terms, and what are we left with? So 7 times y squared gives us 7y squared. 7 times what gives us 21y? Well, 7 times 3y gives us 21y. 7 times what gives us -28? 7 times -4 gives us -28. So 7, so our second step, or our writing down of our first step, is 7, open a bracket, times y squared plus 3y minus 4. And now we're just going to look at the inside of this brackets. That's the trinomial that we're going to be looking at, because we've simplified it. Our numbers are easier. So now we have our double set of brackets. Don't forget your 7, still there. And we know we have y squared, so y has to go in the first spot on the two brackets, because the only way to get y squared is to do y times y. Then what are our numbers for our second part of the brackets? Well, what multiplies to be our constant? Remember, our constant is -4. We're not looking at that -28. We already factored out 7. We're only looking at the -4. What are our factor pairs? 1, -4, -1 and 4, and 2 and -2. Because we're getting a -1, we need to have a positive and a negative our organizing. So this is a little bit different. You could also write -2 and 2, but it's the same thing as writing 2 and -2. So I only write it down once. So then which of these factor pairs add up to be the coefficient of the middle term? Which ones add up to be +3? 1 minus 4 is going to be -3, so that doesn't work. -1 plus 4 is going to be +3, so that's going to work. 2 minus 2 is 0, so that doesn't work. So -1 plus 4 are our pairs, so those numbers go in the second spot. So we have 7 times y minus 1 times y plus 4. and then we can be fully factored. So again, as you can see, there are a few steps that we write down in the actual math, but there are lots of things that we're thinking about, and we need to organize that information in a way that makes sense for us. And now you can do the support questions on page 14, questions 6D through G. All right, so let's do some support or some practice questions. I'm not going to do this expanding question just because we don't have a ton of time, and that's what we did in our last one. I was going to just do an extra practice, but we're not going to do that. We're going to factor. So factor x squared plus 13x plus 40. So first I look and I say, can I common factor? Do I need to common factor? A equals 1, so I don't need to common factor. I don't need to think about that. So I can just set up my two sets of brackets. And then how I do this when I was learning and when I do my own questions is I say, okay, what are two numbers that multiply to be positive 40 and add to be positive 13? That's how I do it. And then I list my factor pairs. So what are my factor pairs of 40? So 1 and 40, negative 1, negative 40. 2 and 20, negative 2, negative 20. 4 and 10, negative 4 and negative 10. And 5 and 8, negative 5 and negative 8. I do this, I organize them so that I'm starting from lowest to the highest, and I just sort of go through it. Again, you figure out what makes sense to you. Now, which of these pairs add up to be positive 13? Well, I can tell that a bunch of these ones are just not going to work. They're just too far away. So here I get down to 4 plus 10. Well, that equals 14. And negative 4 plus negative 10 equals negative 14. But I want 13, so nope. So I have 5 plus 8 is 13. And negative 5 plus negative 8 is negative 13. So negative 5 and negative 8 don't work. So that means that positive 5 and positive 8 are the ones that are going to work. I forgot to put in my x's at the beginning, but it doesn't matter. I can just put in my x's now. I jump to the numbers. And so I'm going to have x plus 5 times x plus 8. And that is all I need to do for this question. You don't have to write down all of these steps, but if you write these down, then I can see what it is that you're doing, what you're thinking, because otherwise I don't know what it is you're thinking or where these numbers came from. Okay, here, this expanding question, I'm just going to briefly set it up because the expanding question is 4x plus 5 all squared. So it's bracket 4x plus 5 bracket squared. So what that means is that we have 4x plus 5 times 4x plus 5. And now it's the same as before. So it's just that squared thing means that what we have, we're going to multiply it by itself twice. And so now you don't just square each individual terms. You still need to use the box method or FOIL or Algebra Tiles to do all of the steps, but you use two copies of 4x plus 5. Okay, number 4, factor minus 10y squared plus 80y plus 200. So first I'm going to look, what is my coefficient on my y squared term? Well, it's negative 10. So that means I need to factor out negative 10. So if I factor out negative 10, I'm left with y squared, because negative 10 times y squared gives me negative 10y squared. So I have to think, what number times negative 10 is going to give me positive 80y? Well, because it's negative and I want a positive, that means I need to multiply it by another negative. 80 is what I want. So 10 times 8 gives me 80. And I need y. I don't have a y with my negative 10, so I need a y. So negative 8y times negative 10 gives me positive 80y. And then I need to think, well, what times negative 10 is going to give me positive 200. Well, again, I need a negative because negative times negative equals positive. And then 200 divided by 10 is 20. So negative 20 times 10 is going to give me 200. So I factored out that negative 10, and now my numbers are simpler to deal with. So I say negative 10, and I write my two sets of brackets, and I know that y has to go in the front spot of the two brackets because y times y equals y squared. And then I need to think of what two numbers multiply to be negative 20 and add to be negative 8. So I'm going to do my factor pairs of negative 20. So 1 and negative 20, negative 1 and 20. 2, negative 10, negative 2, and 10. Now I'm going to stop there because I can already see that 2 and negative 10 works. That gives me 8. So I'm not going to keep listing my factor pairs because I can already tell that those are my numbers. Because 2 times negative 10 gives me negative 20, and 2 plus negative 10 gives me negative 8. So that means I'm going to have one set of brackets being y plus 2 and one set of brackets being y minus 10. So my final answer is negative 10 times y plus 2 times y minus 10. All right, so let's consolidate what we've learned in lesson 2. So we've talked about polynomials and factoring. Remember, the first half we talked about expanding using the distributive law. We multiply each term inside the brackets by the term outside the brackets, and then also expanding and simplifying binomials using this distributive law. We used algebra tiles, the box method, and we talked about FOIL in terms of how to multiply two binomials. The distributive law is just that we make sure that we're multiplying every piece by every piece that needs to be multiplied by. And then today we continued with factoring quadratic relations, where we common factored if possible, and then we find all factor pairs of the constant term, the number term, and all the numbers that multiplied to be the constant term, and we identified which of those factor pairs adds up to be the coefficient of the middle term. That's how we were able to factor. I know it's a lot, and it might take a few times of watching through the videos and pausing and taking breaks and watching in chunks, not watching the whole thing all at 1 hour. That's totally fine. That's why we put them up on YouTube, so that you can do that and you can go at your own pace. So hopefully you can meet the success criteria. From the last video, we did 1 and 2, which were that you can explain and identify polynomial terminology and you can multiply binomials. And hopefully now you're feeling comfortable that you can common factor and factor trinomials when a is equal to 1. Remember, if a is not equal to 1, then we try to common factor first. And if you can't common factor it out, then we don't have the tools to factor it. It is possibly factorable, but we just don't have the tools at this time.
If you have any questions or concerns about this lesson, please reach out and contact me. Give me a call at the office at 807-737-1488 or toll-free 1-800-667-3703. Send me an email to bronwyn.slate, that's spelled BRONWYN.SLATE @nnec.on.ca. Connect with me through Facebook at bslatewahsa. And remember, my YouTube channel is also called bslate Wahsa. All of our course material and supports are found under a playlist called MBF3C, so you can find all of our recorded lessons there to support you. My office hours are Monday through Friday, 8 a.m. to 2 p.m., and I'm willing to negotiate a time to meet outside of those hours if need be to give you the support that you need. Thank you so much for joining me today. Mogich.